Hello, everyone, and welcome to the last rule of differentiation, the chain rule. The idea here is that so far, all the rules of differentiation that we went through came from algebraic operations. So if you add two functions or you subtract two functions, you can go term by term. If you have a product of two equations, you use the product rule. And if you have the quotient of two equations, you do the quotient rule. But with functions, you can have a function inside another function that is not constructed by algebra, so addition, subtraction, multiplication, or division. So how do you compute derivatives in that case? For that case, we're using the chain rule. So the chain rule is the last rule of differentiation. So what is the chain rule? So the idea here is that we have two functions, f of x and u of x, and we want to compute the derivative of f at u of x. So here, u of x is a function inside f of x. So we have this inside function. So the inside function is u of x. So when I'm going to refer to the inside function or the outside function, so the inside is u and the outside is f of x. So f of x is the outside function. And we want to compute that derivative of f at u of x. So here the idea is that when you're computing f at u of x, so if u of x is the interior, you just compute the outside of f and you're computing it using whatever rules you need, and you call this f prime. But, and this is very important, you're not changing the inside. So if you start with f of u, you get f prime of u. So you're not changing the inside. So that's really, really important. And that's typically the number one mistake, is people trying to go inside too soon and not getting the right answer. But you need to take care of the inside. So how do you do this is afterwards, you multiply by the inner derivative u prime. So here, whatever you have inside, you initially don't touch, but then afterward, it's like you're puking out, okay, the inner derivative u prime. So the derivative of fu is f prime u times u prime. Okay, so, and here the main difficulty is really to see what's inside and what outside, and to not mix up like, oh, is it a product or a quotient? This formula, if you compare it to the product rule or quotient rule, is not as user friendly, because you need to, like find what is the outside function and the inside function, and it's not very trivial algebraically speaking. But thankfully in our class, there's only three types of functions that we're going to study: power functions, exponential functions, and logarithmic functions. So we only need to focus on the chain rule for these three specific equations. So what I mean by this is that there's a specific way to formulate the chain rule if you're looking at a power function. So if you know how to differentiate x to the n, and you know it's nx to the power n minus 1, what about differentiating some stuff to the power to the n? Well, if you have some shit to the power n, so you're first initially using the outside formula. So if you have the powering by n formula as the outside function, well, the power, the n, falls up front as a coefficient. The inside does not change. That's the chain rule idea. And the new power is the former power minus 1. And then you multiply by the inner derivative. So you puke out the inner derivative here. So you just differentiate whatever is inside, and you multiply by u prime. And that's the chain rule in the specific context of doing something to the power n. And then we can also look at the special case of doing a chain rule where we have an exponential function and we have some function for the power. So if you have to differentiate e to the power ux, so we know the derivative of ex is ex. Now, if you have to differentiate e to the power of some shit, well, you're going to get e to the power of that shit again, because ex goes to ex, e to the u goes to eu again. But then you need to multiply after by the inner derivative. So afterwards, you multiply by the inner derivative. as you can see, for all cases, these formulas, they always end up with u prime. So whatever stuff you have inside, you puke out after. And then the last special case for the chain rule, if you have ln of something, we know that ln of x is 1 over x when you differentiate. So if you have ln of x, it's 1 over x. So if you have ln of some shit, you're going to get 1 over that shit. And then afterwards, you're going to multiply by the derivative of the inside, u prime. So all these formulas, they share this in common. They all end up with u prime. So because for power rule, xn goes to nx to the power n minus 1, some shit to the power n will go to n times that shit to the power n minus 1 times shit prime. For the exponential one, if you remember that ex goes to ex, if you have e shit, it's going to go to e shit times shit prime. And then if you have ln of x and you remember that ln of x is 1 over x, then if you have ln of some shit, you're going to get 1 over that shit times shit prime. And for us, this is all the chain rule that we need. The general formula, of course, works for every single composition of function or function inside an outside function. But for us, the focus of the chain rule is completely summarized in those 3 special cases. So you need to master these 3. Now let's do some examples. All right, so here we go. Let's compute f prime for the following functions. And of course, we'll need the chain rule. So the first function, f of x, is x squared plus ln of x plus 1, all that to the power 5. You could FOIL this, but if you have a trinomial that you raise to the power 5, this will take you an entire day just to get that computation correctly. This is not something that is fun to do. So here what we see is that we have something to the power 5. So I'm not going to chuck g inside. The way I like to think about this, I like to construct this like box. Okay, so I like to put my function inside in a box, and that box is like protecting my function. So really, I have some stuff to the power 5. So when I'm going to compute f prime, because I know that x5 goes to 5x4, if I have some stuff to the power 5, I'm going to get 5. That stuff untouched, it's in the box, it's protected to the power 4. So really here, same idea. I'm just taking that box that used to be to the power 5. The 5 falls up front. The new power is 5 minus 1, which is 4. And that's the outside. That's the f prime part. And the u, the inside, is not changed. But you need to multiply afterwards by the derivative of the interior. So here I'm going to do it in 2 steps. Normally when you're a pro, okay, you can write the actual derivative here and do it in 1 step. But if you're taking your time and you just want to see things correctly, or if you feel that the inside derivative is going to be a bit more complex, take your time, show me that you understand that this formula is some stuff to the power 5. You get 5, that stuff to the power 4 times the derivative of that stuff. Okay, so that's the u prime part. So every time I'm going to write that arrow with the d, is I differentiate the inside. That's my u prime part. So now I'm done because I already have my first part, still untouched. Don't go inside. Okay, so what's the derivative of x squared? That's 2x. The derivative of ln of x is 1 over x, and the derivative of 1 is 0. That's it. That's all for that question. Again, here, take your time. Understand that you're using the power rule with something inside. It's not x5. It's some stuff to the power 5. 5 stuff x4 times the derivative of the inside, and that's your derivative. All right. Let's do another example. I want to compute the derivative of the square root of x squared plus 1. By the way, the square root of x squared plus 1 is not the square root of x squared plus the square root of 1. You cannot distribute the square root. This is an example of a power formula. This is the same thing as x squared plus 1 to the power 1/2. So I have some stuff inside a power function where that power is 1/2. So when I'm computing f prime, the 1/2 falls up front. The new power is the former power minus 1. So 1/2 minus 1. Again, if you're comfortable and you're writing minus 1/2 right away, good for you. And then times the derivative of the inside. I mean, if you see that it's 2x, just write 2x. Here I'm going to write all the details so that you can see it. So the derivative of the inside is going to be 2x. So let me just simplify my stuff. I have 1/2 x squared plus 1. The inside is not changing. 1/2 minus 1 is minus 1/2. And the inner derivative, the derivative of x squared is 2x. You could leave it like this. This would show very well that you know your chain rule. But because we have no life, let's simplify this. The 1/2 and the 2 and the x will simplify to a clean x. Sorry. And then the minus 1/2 can go down as a 1/2, also known as a square root. So this would be the simplified version. Again, this is nice enough. Okay, that shows very well that you know your stuff. So nice little chain rule. Both of them, I use the power formulation of the chain rule. Like my first example, A, was something to the power 5, and my second example was something to the power 1/2. All right, let's move to more examples. Next, we have f of x is equal to 1 over x4 plus 1. Actually, this one you could do using a quotient rule with u equal 1 and v equal to x4 plus 1. But remember, be careful, u prime would be 0. Okay, so, but me, what I'm going to do, because I want to practice chain rule, I'm going to see this function x4 plus 1 at the denominator. I'm going to bring it up as a power function where the power is minus 1. So when you have like something with no power, it's as if they were to the power 1. So I'm just using that exponent rule where I can bring stuff up and raise it to the power of the negative version. So here, 1 over x4 plus 1 is exactly the same thing as x4 plus 1 to the power minus 1. So I have some shit in the box. Okay, so when I'm going to compute f prime, so for f prime, so minus 1 falls up front. I'm not touching the inside. It's protected by that box. The new power is minus 1 times the inner derivative. Again, here, if you see it, it's times 4x cubed. You don't have to write all that detail. I just want to be clear. So here I multiply by the inner derivative after. So when I clean my stuff, I have minus 1 x4 plus 1 to the power minus 2. And then the derivative of x4 is 4x cubed. 4x cubed plus 0, because the 1 goes to 0. You could leave it like this, or if you really want to simplify, the minus 1 and the 4x cubed will become together minus 4x cubed. And I'm going to bring my x4 plus 1 to the power minus 2 down as x4 plus 1 to the power 2. And that's my nice chain rule. Again, this one can be done using quotient rule. So next example, same idea here. You could also do it with quotient rule, but then for the v prime, you would need to use a chain rule. For me, and this is kind of a maybe an advice, if you have a formula where all the variables are only at the denominator, bring everything up and do a chain rule. It's always going to be way faster. So here I can bring everything up, but be careful when you are bringing everything up. You need to change the sign of your power, because the power used to be 2 down there. It's minus 2 up here. So I have some stuff in a box to the power minus 2. Here we go, my chain rule. So f prime will be minus 2 falls up front. What's in the box does not change. It's protected from your creepy fingers. So protection. So see this as a force field. The new power is minus 2 minus 1. Again, if you can write minus 3, do it. Okay, so here I like to write all the details just for the sake of completeness. So for the inner derivative, if you see that it's ex minus 2 over x, do it. Okay, but I'm going to do it in 2 steps just to show you all the steps. So I'm multiplying after by the derivative of the box. So when I clean this up, I have my minus 2 ex minus 2 ln of x to the power of minus 3. And then the derivative of ex is ex Derivative ln of x is 1 over x times 2, which is 2 over x. And for that one, I'll leave it like this. Okay, so you could bring that minus 3 down as a power 3. Again, it's more for you if you're comparing your answers with the answers at the end of a book or wherever you're doing your exercise. You should be able to see if your questions, if your answers are equivalent. All right, more. Yes, let's do more examples. All right, more examples. So we want to compute again f prime for functions where we will need at some point chain rule, but you'll see sometimes we will combine these rules. So first example, I want to compute the derivative of e to the power minus 3x. So I have something inside the power of e. It's not just ex, it's e to the power minus 3x. So I like to draw that little box for the power. Same thing for the next one, minus e to the power of minus 3x4. So when I'm computing f prime, so two chain rule here. This is the first time we were using e to the power of something. We know ex goes to ex. So if you have e to the power of something, for the first term, you're going to get e to the power of that exact same thing unchanged, but you multiply after by the inner derivative. Now, let's say we're going to assume we're getting better at this. So what is the derivative of minus 3? X is just minus 3, so you just multiply afterwards by minus 3. Then for the second term, same idea, ex goes to ex, which means that e to the power of minus 3x4 goes to e to the power of minus 3x4 unchanged, but you multiply after by the inner derivative because the derivative of x4 is 4x cubed. So if the 4 falls in front of the minus 3, you're going to get minus 12x to the power 3. So you just multiply afterward by the inner derivative. So two chain rule involving the exponential function. All right, now the fun begins because my next function is x squared times, so a little product here, e to the power of minus x cubed. So this function is initially the product of two functions. It's x squared multiplying e to the power minus x cubed. So it's the product of two things. So I need to use a product rule. So my first function, my u, is going to be x squared. And my second function, my v, is going to get to be e to the power minus x cubed. So when I'm going to compute the derivatives for my product rule, u prime, pas de problème, it's 2x. But what about v prime? This is where you have to look at these questions, and really in general, the computations of u prime and v prime are a question in a question, or are questions in a question. And what about v? Well, v is e to the power of something. So I need to use here a chain rule to compute v prime. So e to the power x is ex. So e to the power of some shit is e to the power of that shit again, untouched by your creepy ants, times the inner derivative. So minus x cubed will go to minus 3x squared. So we have, right? So x squared. So I'm doing a little chain rule here, and that's the result of my chain rule. And now I combine those four functions to compute f prime using, remember, this is a product rule first. Okay, so now we're using u prime, so 2x times v, e to the minus x cubed untouched, plus u untouched, so x squared, times v prime, let's put it in a bracket, e to the minus, to the power of minus x cubed times minus 3x squared. And that's the result of that chain rule. So, sorry, that product rule. But yes, in the computation of v prime, that's where we use a chain rule. All right, the next example is very similar to the one we just did, but instead of starting with a product that turns into a computation where you need a chain rule. This one is initially a chain rule where we will need after a product rule. So here, our function is f of x is equal to e to the power of 2x plus x5 times ln of x. So we have a big function at the inside of our exponential function. So our function is really of the form e to the power of something. That something is gross, but it's really just e to the power of something. So here we go, chain rule forever. So here we go. So f prime, because ex is ex, eu is eu again. So you get e to the power of 2x plus x5 ln of x untouched. Resist temptation, don't go inside. But then afterwards, we need, and here because the exponent is complex, I'm going to take my time, so I need to multiply after by the derivative of 2x plus x5 times, this will be important in a minute, ln of x. So again here, did not change what was inside my power in the box, protected. So I multiply after by the inner, by the derivative of the inside. So I'm done with the beginning. So there's a lot of writing the same shit again here. So e to the power 2x plus x5 untouched. And now I need to multiply by the derivative of the inside. So the first term, 2x, will just go to 2. So that's a nice linear function. But x5 times ln of x, this is going to be done using a product rule. We have the product of two things. So here we go. What is the derivative of x5? That's 5x4 times ln of x. So that's really my u prime right there times v plus u, which is x5 times v prime, and the derivative of ln of x is 1 over x. So that's really my formula plus u times v prime. And that's these two terms, that's the result of the product rule. So this question is really a chain rule followed by a product rule inside. So you're in your computation of u prime, we add a product. So these two questions are really interesting when you combine, when you look at them together. The B, example B, was a product followed by a need of using the chain rule. This one is a chain rule first with a need of using a product rule after. Let's do the other one. Actually, the other one is a bit simpler. I want to compute the derivative of ln of x squared plus 1. So I have something inside ln plus, or minus, sorry, ln of ex plus 1. So here, this is the first time I'm going to use a chain rule using the logarithmic function. So here we go. So for f prime, so I have ln of some stuff. So you get 1 over that stuff. So you know 1 over x, ln of x is 1 over x. Ln of anything will be 1 over that anything. And afterwards, you multiply by the inner derivative. So derivative of x squared. So again, my box unchanged. And you multiply after by the derivative of x squared plus 1. Remember, add the numerator at the upper level. So it's 2x minus. So same thing for ln of ex plus 1. You get 1 over the inside, untouched, protected by the box, and you multiply after by the derivative of ex plus 1, because the derivative of ex is ex, because the derivative of 1 is 0. That's it. If we clean this up a little bit, you're going to get 2x multiplying 1, so you get 2x at the numerator, over x squared plus 1, minus ex multiplying by 1, which will be ex, over ex plus 1. Maybe you've seen the chain rule for ln of u as u prime over u. That's exactly the same. Okay, so you can use that for sure. All right, for the next two examples, I'm going to do it like a pro. Okay, so if you find that it's too quick, it's fine. Just try them up on your own, but I will show you how you will be able to do it eventually with good enough practice. All right, like I said, I'm going to speed run those two last example, but make sure you try them on your own. They're really interesting questions. So here we go. So f of x is ln of x times ex minus x plus 1. First thing I notice is that everything is inside the logarithmic function. This is initially a chain rule. So here we go. So if I compute f prime, I get 1 over everything unchanged. So xex minus x plus 1 times the inner derivative. So here x ex minus x plus 1. I mean, I could have done it in one shot. I will do it in two shots. So you get 1 over x ex minus x plus 1, so unchanged. But you can see here the first term is actually the product of two things. So I'm going to use a product rule. So the derivative of the first one, derivative of x is 1 times the second function on touch plus the first function on touch times the derivative of the second one, which is ex. So those two terms here, that's the result of my product rule. The derivative of minus x is minus 1, plus 1 is 0. That's it. That's all for that question. So a chain rule followed by a product rule. So my last example of that section, I have f of x is x cubed plus ln of 4x. So I have ln of something here. So this will be a nice chain rule for the second term. So the first term, the x cubed is basic. And then for the second term, I have minus e to the power minus 2x that multiplies ln of 1 plus ln of x. This is going to be done using, so it's a product of two things. So this is a product rule. So here we go. Let's go. So for f prime, x cubed is 3x squared. Ln of some stuff is going to be 1 over that stuff. Protected here, multiplied by the inner derivative. What is the derivative of 4x? It's just a clean 4. Minus, I'm going to open a bracket here just to avoid sign mistakes. What is, so if I call the first term u and the second term v, my u prime is u to the power of 1 minus 2x. So I'm going to get, when I'm computing u prime, e to the power of 1 minus 2x, because by chain rule, the e function does not change. But then you need to multiply by the inner derivative. 1 is 0, and minus 2x is minus 2, times the second function, so ln of 1 plus ln of x, plus the first function untouched, that's my u, times v prime. All right, so what about v prime? We have ln of something, so you get times 1 over that something, which is 1 plus ln of x, times the inner derivative, and derivative of 1 is 0, derivative of ln of x is 1 over x, so you get 1 over x, and that part is the v prime. And as I said earlier, you can just do it. If you can just do it in one shot, you don't have to worry about, like simplifying it. This is as good as it gets. Okay. Again, I'm fully aware that I'm doing the last two examples kind of quickly. Try to do it on your own. If you can do these two type of questions, you'll be more than ready to, deal with any questions coming your way during evaluations. All right, for this section on the last rule of differentiation, that's it. That's all. Bye-bye.